diffuser, diffuser. So what is meant by diffuser? When a fluid is decelerated, when a fluid is decelerated in a passage, of smooth varying cross section, causing rise in pressure along the stream, then the passage is called as diffuser. So in the other word, we can tell diffuser is a device which recovers the pressure in a passage of varying cross section. So the diffuser is the exact opposite. Of nozzle. This is very important. Fine. So we are going to derive an expression to find the efficiency of the diffuser. Expression for diffuser. Diffuser efficiency. So before deriving the expression, let us have a look at the HS diagram of the diffuser. HS diagram. So this is your enthalpy versus entropy. So in enthalpy versus entropy, we see constant pressure line. Let me name this as P1, P2. So as I said you, it is the exact opposite of the nozzle. So basically what happens in a diffuser means it raises the pressure the pressure is being risen or rising. So this is your process 1, process 2 dash. So this is your isentropic process. Now if it is an actual process, there will be a slight variation. There will be a slight variation in the graph. So let me call this as 2. 2. Okay. So the formula for the efficiency of a diffuser, eta diffuser, equals isentropic enthalpy change. Isentropic enthalpy change divided by actual enthalpy change. Okay, isentropic enthalpy change and actual enthalpy change. So efficiency diffuser can be written as H2 dash minus H1. There is no dash. H1 divided by H2 minus H1. H2 minus H1. Okay. So this is the formula for our efficiency of the diffuser. Let me call as equation 1. So what is the next step is? In diffuser, velocity 1, which means the inlet velocity of the diffuser will be very large than the exit velocity. So what about the pressure? So exit pressure will be more than the inlet pressure. So it is exactly opposite of our nozzle. So in that case, efficiency of diffuser we can write as V2 dash minus V1 square dash. V2 dash square V1 square. So an isentropic without any friction, V2 dash square minus V1 square divided by V2 square. So what if V1 will be more? So I need to change this. Just a moment. So V1 V2 dash, okay, V1 minus V2. So this is the efficiency with respect to the velocity of the diffuser. The velocity of the diffuser. Now, from TDS equation, TDS equals H plus H minus VDP. So let me call change in enthalpy. So this is our equation number 3. Equation number 3. So from isentropic process, from isentropic process, dH is equal to VdP. So integral 1 to 2. So if I apply limits, my change in enthalpy I'll get. Similarly, I'll get my change in pressure taking specific volume outside. So H1 H2 minus H1 equals, so let me take this as H1 dash as an isentropic process. So V I can write as 1 by rho, as we know rho is equal to 1 by V, that is nothing but specific volume is inverse of density. So P2 minus P1 dash. So H2 minus H1 dash equals to P2 minus P1 dash by rho. No. No. Let me call this as equation number, which should be 4. Now, substituting in equation 1, we get efficiency diffuser H2 minus H1 dash divided by H2 minus H1. So we have other equation also. Let me write 2. That is P1 dash square minus P2 Okay, dash divided by v1 square v2 dash square. So we can correlate these two equations. So efficiency diffuser can be written as, in this value h2 minus h1 I can write as p2 minus p1 dash divided by rho divided by, instead of this let me replace this one, v1 square plus v2 square. So when we have a observation on this equation, this is nothing but pressure difference, this is nothing but velocity difference. So this is a potential energy and kinetic energy, similar formula. So efficiency of diffuser can be written as P2 by P1 dash by rho into V1 square minus V2 square dash divided by 2. So efficiency of diffuser I can write as P2 by P1 into 2 divided by rho P1 square minus P2 square. So this is our efficiency of diffuser. So I think this concept is clear. Let me have one more concept, that is nothing but pressure recovery coefficient. Pressure recovery coefficient. Pressure recovery coefficient. So when I write in dark, it seems to be very important. Yes, it is very important indeed. So what is this pressure recovery coefficient? So it is a ratio of pressure recovery coefficient. It is denoted by Cp. It is a ratio of two quantities, that is static pressure rise, static pressure rise to the initial kinetic energy. Initial kinetic energy. So Cp I can write as, what is the static pressure? It is P2 minus P1. It is a pressure P2 minus P1 divided by half rho rho sorry, Something happened to the stylus. Couldn't able to rub this. Half into v1 square. So this is the basic definition of the pressure recovery coefficient. Pressure recovery coefficient. So I think we'll stop at this stage. We'll meet you next class.